So what are we gonna do? So when we estimating the causal effect, we condition on the compounder so that we close the compounding path, and you do not condition on the mediator, which means we keep it open, all the paths affect the C to F when we want to see the exposure and the outcome. And you may, that's why this is may, and computing exposure. You don't need to do this when our model is completely linear, but if it's you have any doubt it might not be the linear, then you can condition on, which means it's close out. So I really want to find out effect of the x3 on the y. Then what you have to do is you have to close the confounding. So you have to condition on the x1 and x2, right? And you have to keep it open x4. This is the still x3's effect on y. This is direct effect on y. So you have to keep it open. And I want to cut off to the x5, so I had to condition on x5. So what you have to condition on is I have to have a x3 because this is what I'm trying to find out. And then I have to include the model x1, x2, x5, which is all the variable I condition on. I'm taking out the x4. If you include the x4, actually the effect of x3, that if the coefficient will take it out the sum of them. X4 will take out the sum of x3 effect. So that's why we don't include x4. So still this kind of effect is x3's effect on the y. So instead of x4, so I want to see what is x3's effect. But I have to condition on x1, x2, x5. So I have to include this conditioning variable and use this model. And then if you got a coefficient of the x3, then you can estimate that is my causal effect on y. However, from this result, you got the beta here, right? Coefficient of x2. Can I use this one as a x2's effect on y? No, you cannot do that. Because this is the only you can use this number. You will if you do the regression, you will get all the beta here. But this beta is not the correct effect on y. So you cannot use these numbers here. I'm only trying to estimate the effect of x3. Why is not? If you want to see the x2's effect on the y, right? Then what you have to do is this is the mediator. X3 becomes the mediator, so you have to keep it open. And this path is also still x2's path, so x4 should be open. Directly connection. And x1 is kind of x3 is a mediator, but x1 has this kind of thing. So I want to cut off the x1. And I want to cut off the x3. So I have to condition on the x1. I have to condition on the x5. So if you want to find out the effect of x2, you have to set the model this way. This is a total different. This beta will be different than this beta here. So this, in terms of causal effect, this beta doesn't mean anything. Okay? This beta is the number I want to find out. What will be the coefficient of x3? And all others coefficient is meaningless. If you want to find out x2's coefficient, you have to set it up this way. So whenever you want to find out some certain variables effect on our outcome, you have to set up it individually. You cannot utilize some other models coefficient. Okay, so 10th step to draw the DAGs is develop and state the clear research question. First, you have to find out what you are trying to find out. You cannot just collect the data and then less study about data, less what you can find. In that way, you cannot draw the correct. You never know your DAG is correct, but you will have a pretty bad DAG. So you have to state what is the thing you want to find out. And consider and then state your context. That's quite important. And draw your DAG as early as possible. Maybe you have to draw it even before the data collection. So if you have a complete DAG, maybe when you collect the data, you will add some value, or you will collect the data in different way. Depends on your DAG. So you better have a DAG as soon as possible. And get help. Don't draw it alone, because this is more like a brainstorming procedure. So you may want to have some different point of view. So you get a lot of help from the expertise on the context, and you might ask many people and accept the different point of view. Then you can complete your DAGs, including the all relevant variables. So you might doubt this variable doesn't matter, but unless you are sure, you have to include everything. Later, maybe you can cut it off, but you better keep all the relevant variable, unless you are sure that's not. Draw DAG in the temporal order. Temporal order means what is the time order, which one happened first. This one happened first, and then the other things happen later, and then you can draw the DAG, the node in the temporal order. And then and after that, draw the forward arc, because the thing that happened later cannot affect the thing that happened before. Physically, that's impossible. Yeah, we are not talking about time travel stuff, right? So that's why we draw. This will help you draw the DAG in the time order, and then you draw always the forward arc. So the variable that happened first can cause the variable that happened later. So forward arc, right? And check update your DAG against your data. So you see the data, and then you may update the DAG, and then you're using your DAG the inform and interpret your model. So whenever you do the analysis and then presentation, you better share and then publish your DAG, so that everybody can see what is your causal model. So again, the DAG doesn't give you any answer, but it will help you to build up the better model. But again, still you don't know that is correct one. Sometimes it's the people misunderstood the DAGs. They will help you. It will not help you. It will help you build your model, but it will not help you prove effect is causal or not. You can get a best estimate, but you cannot say this is a significantly causal effect, has a causal effect. You cannot tell that. So you can get a just estimate effect, and that's the best estimate, but you don't know that is wrong or not. And DAG does not tell you whether the effect is harmful or productive or the meaningful or not. It doesn't give you anything. It doesn't tell you the interaction is present or not. Again, DAG doesn't give you anything. Yeah, something like that. It doesn't tell you cause is a significant or not. Again, it doesn't tell you. The DAG is just kind of tool when you build up your causal model or yes. Um, um, that's it for the causal inference. Um, Causal inference is it itself has quite a lot of the context. That's why we have a book. And if you are interested in, there's a book. The same author I refer the when I prepared the causal inference in the statistics of the premier. The same author, but this book is for the general audience. Which means he didn't use a lot of mathematics here. Yeah, yeah. Context itself is the trying to explain how we find out the causal effect or not. However, I mean, the author trying to not to use a lot of mathematics there. So the main target is the general audience who doesn't major the statistics or kind of things. Uh, so it's kind of the right. I mean, book is not small, but it's kind of light reading compared to any technical textbook. Um, there's a lot more about the causal inference, but this is just brief introduction. So if you see any research about the causal inference, then you may not know all the details, but you can at least you can understand what they are doing, what they're trying to do. Okay, that's it for this causal inference chapter.